about some kind of cool ideas with pistons and rings and timing and counting cycles, and I wanted to share that with you guys. Hey, Charlie, Garen, how you guys? It's great to see some friendly faces pop up here. Hey, Ron and Nat, you guys. Charlie, man, thank you for the business, my friend. Ron, thank you, brother, for the encouragement and the laughs. When I was doing my pistons going up and down really fast, Ron told me I needed to get me a Kermit the Frog puppet to put on there so he could be moving up and down pretty fast. That would have made me laugh myself. Hey, Michael, Jeff, Scott, Jim. That's my big nasty guy. Yeah, Chris. Hey, Chris. Ronnie, Claude, Kevin. Wow, we got a good little crowd growing up here pretty fast. Hey, Mary. Mary Gold. Mary Heath, how you doing? Scott, I don't know if I'm going to have anything some of you guys want to hear about, but I'm going to talk technical. I'm going to talk technical on this Tuesday. In Americus, Georgia, over there on the East Coast, it's 6 o'clock, I think. And over here in Tennessee, it's about 5 o'clock. And over there on the left coast, I think it's still about 3 o'clock over there. So you guys are probably still working and not able to watch live. But please remember, yep, Jim Phillips, you were the first. You were the first M8. I think we worked on yours in 2016. We built a Milwaukee 8 for Jim Phillips before they even invented a Milwaukee 8. I think. He sure won't. He wanted to know why. Every bike we built after his made a little more power than his, and I kept trying to tell him, man, you were the first. Every one of them after that's going to be a little better. Hey, Sam. Hey, thanks for the moon eyes. Appreciate that. That's cool. Hey, everybody asks all the time, say, George, what kind of socks you got? Oh, man, Jackie fusses me because I don't match good, but I got on my pink flamingos. They look like they're, she says, mint green and pink with some flamingos on them, and I don't know what that matches. But, hey, man, I'm 66 years old, and my wife doesn't dress me yet unless we're going out. And I figured since I'm really at home, I'm not really going out, even though the whole world can see me. I don't know. Is that the same as dressing up to go out? Hey, Manny, Jimbo. Yeah, you're right. You're right, Jay. All right, look, I'm going to flip over to the board and show you some stuff that I want to talk to you about, and it'll be a lot better looking than me. Thank y'all for tuning in. Let's flip right over here and go look. Let's see what you do right here. I'm going to learn it. Number 77. Okay, let's go over here and see what we can see. We'll get where I can point to it a little bit. A couple things I wanted to tell y'all. Hey, Roger. Hey, y'all. Let's see if I can get this tuning right here. Oregon. Okay. I've drawn a blue cylinder wall, and I've drawn a top ring, a second ring, and a three-piece oil ring, okay? Yep, I got my pink flamingos on. Stephen and Harvey, Chris, Michael, good to see you guys, man. All right, I'm going to talk about something else today. I want to tell y'all that I get asked every Tech Talk, which so far that's been 77 of them. I get asked every Tech Talk. Somebody scrolls across this little screen right here. That's where y'all's names are coming up right here. And I'm trying to look at what I'm doing over here and up here, and I keep seeing these little names and these friendly folks' faces. Where y'all at? Huh, there you go. I see these little names come across up in here, and it's distracting because I want to say hi to Alex and Kelly and Scott and Jason and all those folks, but I'm really trying to stay over here and focus on what I'm talking about. So I will do my best. Maybe I can address some of these questions and some of these comments after the show, but I want to talk about what I'm going to talk about while I'm live, okay? All right, what I wanted to kind of hone in here, yeah, that's funny, right? Hone in. What I really wanted to zoom in on here was this this relatively smooth and straight cylinder wall right here, just freehanding it in. And then this barrel face ring, as you can see, it's shaped, it's got a ball face on it. It's not really a ball, it's not really, a 360. It's it's more of a barrel shape. It's probably just a gradual barrel. But anyway, the center of the ring on this top ring is the only thing that touches the cylinder wall. So if it's a lot wider or a lot skinnier, the contact point is still the same. What we have learned over the years, starting within Pro Stock, of course, was getting rid of these really big rings that come on the original equipment pistons back in the days, and the Chevrolets and Ford Chryslers and the Harleys. Man, those Harleys, man, those shovels and knuckleheads and all that. And I ain't making fun of anybody's shovel head or whatever shape your head is. I'm not making fun of you because I have a weird shaped head. That's why I haven't shaven bald yet and wear a hat every now and then. But anyway, about the head shape, these rings that were on those shovels and on those knuckleheads and pan heads, they were so big, and they would get worn flat, and they would chrome plate them, and they would wear out the cylinders, they would wear out the rings, and it would generate so much heat between the friction here that it would actually heat up the oil temperature. You could see the oil temperature on the engine when you put that little dipstick with the thermometer inside the dipstick going down in your oil tank. You could see the temperature going up. These little lighter rings we've gone to now, we're doing less than 40 thou thick rings now. We're doing 0.9 millimeter. I think they're 0.36. Those are endurance rings. 0.36 are endurance rings. And back in the day, there were some 0.80s, 0.90s, 0.60s. An 0.62, they called them a 16th. A 16th top, a 16th second, and then a 5/16 oil ring. And I'm telling you something, you couldn't pull. If you hooked a fish scale, like you measure how much a fish weighs and you hang him on a hook, if you put a fish scale on the wrist pin and tried to pull it through the cylinder with the 16th, 3/16, whatever they were, I forgot. I'm not an expert on that, what they used to be. But anyway, they used to be so hard to pull, it would take you about 30 or 40 pounds of pressure to pull the piston through. And if you had that in a V8, imagine how hard that would be to pull through. But what we have learned is by reducing this cross-section this way and this way, and really concentrating on the ring land in the piston to make it very, very, very precise. And then buying these rings from Total Seal where they are ground, diamond ground, really precise. So we have a beautiful match, a mating surface between the piston and the ring right here. And then the compression on top of the piston, and I know this is very popular right now, is for the compression to come in and go through this crevice volume between the top of the piston and the cylinder. And I'm going to hold this up here so you can see. This piston gets really close to the cylinder right here. So this is called the crevice volume between the piston and the cylinder wall. That's this. I've enlarged it really big. Made it bigger. But that area right here is not very large, but the combustion pressure goes here, runs along on top of this ring, and it gets behind it, and it blows this ring out. So when the pressure is really big in the cylinder and chamber, it leaks down here and gets behind the ring and pushes it out. And then, of course, on ours, we use the gas ports. That's what we've always used, probably for 20 years. We use them on endurance racing. We use them on road racing. We use them on street bikes. We use them on drag racing. NASCAR guys, even cup cars, use them. Everybody uses the top gas ports now. Now, there's a real popular lateral gas port out there that you can buy from all the piston manufacturers where they will bore a hole right here through the side of the piston. They'll bore a hole right here and let the pressure come down and get in this little hole and run back here and blow this ring out. But they'll only have like 10 of them or maybe 8 of them around this piston, so you won't get much pressure there. And then now they have a really cool ring that Total Seal has come out with that has the gas ports in the ring. Like they'll put like a little dent, a little ditch across the top in the same place that those radial gas ports would go in. Now, I am a top gas port guy, and I'll tell you why. Because we don't need crevice volume to get this to work. Never mind what's going on here. We want this close. We don't want this piston in here rocking. And I'm going to tell you in a minute, we're going to move over here to this drawing, and I'm going to show you about some piston rocking. But right now, we're going to be talking about these rings. And if this piston rocks over on one stroke and rocks over on the other stroke and rocks back over on this stroke, and this right here comes down to 0, where this piston gets to where it's hitting here, somewhere in the bore, it can be only here, it could be only here, it could be only here, and it could be only here, but somewhere this is going to get over next to the cylinder wall, and these lateral ports and the gas ported rings aren't going to get a uniform pressure on the 360. In my opinion now, please understand, this is in my opinion. Now what we've got here is we've got top gas ports all the way around, and these are drilled halfway down the back, halfway the depth of the ring, so that we can get an open hole here where the combustion pressure goes through this gas port, gets behind this ring, and pushes it out. So this ring, doing it this way, this ring can have less tension. This ring can be a little bit weaker tension because we don't need it to be all it can be when it's one of those big 16ths or one of those really large rings. We don't need this to have a lot of cylinder wall pressure because the combustion pressure is going to put it out there when it needs to be out there. And please understand, these are only my opinions. Now, this is the accumulator groove, which is in between the top ring and the second ring. This accumulator groove is once this pressure, once we're going to lose some, we're going to get some blow by, some combustion pressure is going to get by this top ring, and when it does, it's going to build up on top of this second ring. And when it builds up on top of the second ring, the pressure in between, this pressure in this chamber, in this area, will build up enough to make you lose seal. This really nice seal that we have worked really hard to get diamond ground rings and real high precision ring lands so that we can see. I'm doing Tech Talk Tuesday, you guys that are messaging me and calling me. I'm sorry. Doing Tech Talk Tuesday. Can't talk on the phone right now. Sorry about y'all. Got to call back another time, or you got to message me another time. But anyway, we've got a real high precision ground ring land here, diamond cut. We have a real high diamond ground profile, low profile, smooth profile finish here. So once this pressure builds up under this ring, it will tear this seal away, and then we're going to have massive amount of blow by. Now, what we have done over the years is we have changed over to this a scraper. Instead, at one time it used to be 2 compression rings here, which was really a long time ago, because if they thought that if the compression got by this one, then this one would hold it. And then they even sold, the internet folks, the marketing folks came up with a gapless second ring so that your leak down test would show 0 leak. If this ring leaked a little bit, this one was 0 gap, so it wouldn't. So an engine builder could go to his customer and say, man, your engine's got 0 leak down. I don't know how it's smoking. I don't know how it's blowing oil out the valve covers. It has 0 leak down. Check it yourself. Plug the air hose into the spark plug hole and blow it up on top of this ring, and it's 0. Well, when it's running, it doesn't work that way. Several things this ring does. One is it takes the heat out of the crown of the piston, which is the hottest part of the piston, puts it into this ring, and then that ring dissipates the heat into the cylinder wall, and then the cylinder wall dissipates it through the fins that stick outside the cylinder. Or on car engines, it goes into the water jacket. But this Napier second ring is an oil scraper. It is made to scrape oil off the cylinder wall and be designed to leave just enough to lubricate the top of the piston here and to lubricate this ring, but without contaminating the combustion pressure and the combustion, how clean. We don't want oil. We don't want oil in the combustion chamber. We want to make just air and fuel and burn hydrocarbons here, not a bunch of oil. So we got compensator grooves to accumulator groove, not a compensator groove. All right, I just caught myself making a big boo-boo there. So it's not a compensator groove. It is an accumulator groove. It accumulates the built-up pressure between the rings. So this groove, you don't want this groove to be so awesome that it undermines what this land is for. The number one job that this ring land has right here is to hold this one in place. The combustion pressure does not affect this one as much as it affects this one, because this first ring, the top ring, the compression ring, is supported by this second land. So if you build a really massive compensator, accumulator groove, it can undermine the support that this ring needs. Please understand that, you guys, these are my opinions. Now, So what is causing the trouble where you need an accumulator groove to accumulate the pressure that builds up, that gets by this ring, builds up on top of this ring, and you need an expansion area for you to accumulate that pressure. What causes that? Well, it's ring seal. So we got to do a better job with the finish on the cylinder walls. We got to do a better job with the finish in the pistons. We got to do a better job with the ring lands, and we got to do a better job with what rings we use and how they're installed. And the combustion pressure going in behind them to seal them up, so that when there is major pressure in the cylinder, that we can keep it above this ring. Now, dropping down to the three-piece oil ring, there is a hole drilled in the pistons. Let's see if I can get my ink pen in it. There's a hole drilled right here. That is the oil drain back hole. On the inside of the piston, you can see the holes right here. These drain back holes are all the way around, and when the scraper scrapes oil off cylinder wall, it feeds it to this three-piece oil ring. This three-piece oil ring grabs all that oil and feeds it back through this hole, and it drains back inside the engine into the sump. Now, you guys have heard of a vacuum pump. I'm not going to spend a lot of time on it, but the one way a vacuum pump works really good is you put vacuum in the bottom end, in the crankcase, and it pulls the vacuum through these oil holes. It gets up in here, and then it comes up and pulls on the bottom of this ring, so this ring seals up better. So you end up with, you got less pressure under the top ring because vacuum comes in through these holes. So these holes actually go both ways. Vacuum comes through them from the crankcase, and also pressure of oil coming off cylinder wall goes through them. So that thing, this is a fast moving part right here, where this hole is drilled right here. I don't know if y'all can see them good. And here is my accumulator groove, and this has been worked out over time, how big this needs to be and how thick this second land is. This second land right here is what holds up all the pressure. You can have, on a Harley, you can have 500 horsepower above this ring. So you got to have some strength right here to hold this ring in place. Because right here, this ring right here is in here trying to come out. It's trying to bend it. It's trying to peel it off. It's trying to pull the piston away from it. It's trying to bend it. It's trying to pull the piston away from it. And you want this ring to stay 90 degrees as much as it can to the cylinder wall. So we want to cut down on the rock that goes in here, okay? Another thing is, I didn't invent any of this, you guys. It's just happened while we were learning in Pro Stock what to do to make these work. One more thing I want to tell you while we're looking at this piston. I want you to see how skinny this area is right here from this big intake valve to this bore. This is a 4.310 bore piston. This is for the Screaming Eagle 131 style stage 5. This is our improvement piston to make that 131 run like it should. And if you look on the exhaust side, you'll see that there's a lot more deck here because the exhaust valves are smaller than the intake valve. So you got this more deck here. So you can tell this side is the intake because we're close with big valves. Can you see that the intake valve pockets are bigger? They're closer to the bore. And then on the exhaust side, the exhaust valves are smaller, so they're further away from the bore. Also, you'll notice that this piston, the major thrust is a full skirt. It is not notched. The front of the rear piston, which this is the rear because this is the intake pocket, this is the exhaust pocket, so this piston would go in the back of this engine. The notch is because these pistons are so big they hit each other when they go up and down in their strokes. And I'm going to tell you about why this one's notched and why the front one is not. I'm going to move over there now. Now I want to explain to you how this works. Can you guys see me okay? I see I don't have a really big... All right, you don't have to buy an M8 to go fast. You just take what we're talking about and do it like we did for 15 years to the twin cams. You just take the principles and you take those ideas and you use them on every engine, not twin cam, not Milwaukee 8. You use it on Chevrolets, Chryslers, Fords. That's what we did. This idea goes into single cylinder dirt bikes. And I'm going to tell you about this Harley engine right here. This is not an M8. This is not a shovel head. This is not a twin cam. This is a 45-degree V-twin. I know you can't tell by looking at it that that's what it is, but that was my intentions for you to think that's what it is anyway. This is the rear. This is the front. We're looking at it on the cam side. And I want to tell you about all these little circles and all these colors. This is what I drew right here. I drew 405 and 315. 405 and 315. Okay, that's what happens when you build a 45-degree V-twin that has a common pin for the rods. The rear cylinder fires, bang. The engine rotates 405 degrees before the front fires, bang. And then the crankshaft rotates 315 before it comes back up on the rear. And then it rotates another 405 before it comes up on the front. So this engine, all engines, V8s, V12s, 4 cylinders, Suzuki Pro Stockers, single cylinders, whatever, they're all single cylinder engines in my mind, in my world, that are connected to a crankshaft. In other words, a 4-cylinder Suzuki is 4 one-cylinder engines hooked to one crankshaft. A V8 is 8 one-cylinder engines connected to a common crankshaft. That's how we think. That's how I've been thinking about it my whole career, because each cylinder has a different personality and a different requirements, has different needs, and it produces different power. I am sorry if you think that the rear cylinder will make the same power as the front cylinder, or the front cylinder will make the same power as the rear cylinder. They do not. And if you spend a lot of time to make the strong one make less power so they'll be equal, it will not matter. So in my estimation, you should try and get the most you can out of this engine and get the most that you can out of this engine. And Harley gives us the opportunity right now we have a fuel injection nozzle stuck in here, and we have a fuel injection nozzle stuck in right here, spraying right on the intake valve. And we can turn these on and off when we want them. And the spark plugs are fired by 2 different coils where we can turn them on and off when we want to. And we can change the ignition timing offset on the front and the rear separately of each other, and we can tune this thing with 2 different compression ratios, 2 different cam timings, 2 different ignition timings, 2 different injector timings. These could be, this front cylinder could be completely maximized to its major potential, and this rear cylinder can be completely maximized to its maximum potential. And then you have a really, really cool engine that is making some power. They do not try to make the same power. That would be a mistake in my opinion. Now, the problem, not the only problem, but it is a situation that we have to address with the V-twins is, let me move this camera around, y'all try not to get seasick on me, is if you have a 2-in-1 pipe, which works really well on these V-twins, it has a collector where the 2 head pipes come together and the engine and the exhaust communicates right here in this collector. If you have one throttle body with a common plenum manifold, like a stock Harley, like a twin cam, a Milwaukee 8, and your throttle body comes out the side or your carburetor comes out the side, I stood this manifold up just for me to be able to show you what's going on. But this is an intake collector, like an exhaust collector. This is an intake collector. So these 2 cylinders communicate through this collector. These 2 cylinders communicate through this exhaust collector. So with that being said, we have to be mindful of the 405 315 deal. Because think about it. The rear fires, engine goes all the way around, front fires, the engine goes all the way back to here, it fires, goes all the way around, this fires. And there's also, let's just take this one cylinder right here and talk about him for a minute. Just the front cylinder. All right, the piston goes down on the intake stroke. It goes up on the compression stroke. It goes down on the power stroke. And it goes up on the exhaust stroke. And then it goes down on the intake stroke. Every time there's 4. This crankshaft has to go around twice to do those 4 strokes. Down, up, that's 1 revolution. Down, up, that's 2 revolutions. In the meanwhile, this guy's got a different timing going on, the rear, because his deal, one of them's on 405 and one of them's on 315. So one guy's going to get cheated right here in this common collector. This is a collector, intake collector. One cylinder at 6,000 RPM. These pistons, at 6,000 RPM, these pistons are going up and down 100 times a second. I can't move my hands or my Kermit the Frog puppets. How about that, Ron? That's for you. Okay? Now, I'm going to break this down just real close here and try and see if I can get anybody to help me understand this. I drew the rod pin in orange, and I drew, what is this, brown? The rear, I drew the rear rod pin in brown. I think that's what that is. And I'll come back and look through these notes and see if I can help you guys understand it. But when this piston's at the top, this rod pin, this orange rod pin, is all the way up. This is TDC. When it is 90 degrees between TDC and bottom dead center, it is 90 right here. So this rod looks like this with the piston at the top. This rod looks like this with the piston at 90 degrees, at the crank at 90 degrees, and this rod looks like this when the piston is all the way down at bottom. Conversely, this guy, when it's TDC on the back, the crank pin's here and the rod's here, and when it's 90 degrees between top and bottom, this rod is here, and then when it's at the bottom, this angle's here. Now both of these rods are hooked to this one pin. You talking about some kind of goofy looking thing. And with all that going on, you got the different, this one happens sooner than this one happens. This one fires first and this one happens. So one pipe, when you do, all these guys work so hard to do equal length exhaust. Their timing is right on one and wrong on the other at some RPM. At another RPM, the timing is right on this one and not on this one. So I'm not going to tell you or act like I know what the primary lengths need to be for the rear to make the power band be correct for the front and vice versa. So what I'm going to tell you is that's why exhaust systems are a really good cut and try. I'm sure there's a simulation program that costs a lot of money that you might be able to put some enough input in, but I believe the guy that would put the input into a program like that would tell you, I believe we would leave him behind cutting steel pipes up and building a short one and a long one and a long one and a short one and shorten it up and lengthen it up and run it on the dyno. We'll get it done quicker than he can put the input into the simulation program. Same thing going on. The reason we learned this is back when we were running the Pro Stock 160 S&S engine, 160 cubic inches, is we ran one intake system on the rear and we ran one intake system on the front, separate of each other. They were called independent runners, and they looked like this going on the engine. One this way and one this way, and they were not connected to a common plenum. So we had one intake for this one and one intake for this one. We had two straight pipes tuned to the right length for the rear, and we had a straight pipe tuned for the right length for the front. And when we did that, we were able to tune this engine and give it all the fuel it needed, and tune this engine and give it all the fuel it needed. And then the ignition time had wanted to be different on both of them. And I'm running out of time really fast, but I'm going to tell you a real quick, short piece about this. When the oil is coming off of these rods, coming off the rod pins, and this crankshaft's coming around, it is slinging oil straight up in this cylinder. So when this piston's going up and down right here, it's got oil splashing on the wristband and on the crown. And then when this piston, the oil comes off of the crank here and it slings it this way and it misses this piston. This oil misses it. This oil drives by this one and drives right into this one. So this piston, if all airflow was equal, this piston could run cooler than this one. So you should be able to put more compression in the rear, just a little bit, and you should be able to run a little bit more timing in the rear, and you should be able to run a little bit different tune on the rear than the front. Now, looking at a V8, let's look at this as a V8. Here's a harmonic balancer. Here's the driver's side. Here's the passenger side. Car's coming straight at us. Same thing. The oil slinging off this crankshaft is missing the driver's side for cooling, but it is slinging straight up into passenger side for cooling. So these two guys are going to want different tunes. Anyway, I'm running out of time. I'm sorry that I hung on too long on these subjects. I'm going to flip you back around so I can say hi. Whew. But yeah, I'm fired up about it too. All right, let me get this up out of here so I don't have to look. There we go. I am challenged, cell phone camera challenge. Are you there? Y'all didn't lose you, did I? Okay. Anyway, thank y'all. I'm going to review these notes. These names that are coming by here, all these names right in here. First of all, I'm very thankful for you guys to call and check in, and we'll watch this. And hey, Chloe and Bryce, Corley, cool, man. I just want to say thank y'all. I know it's a lot of action. It's a lot of words. I got wrapped up and fired up about it, and time's up. But look, stay tuned. Number 77 is in the books. Thank y'all. May God bless y'all. I love y'all. Come back and watch me next Tuesday, and we'll be here, and we'll do some more of this cool stuff, and I'll try and break it down.